Hi, I want to describe some of the things that we see in liquids. So I call this liquid descriptions. Some important words that you need to be able to attach to liquids. The first one is viscosity. Now viscosity is the measure of resistance of a liquid to flow. So it's the ability of a liquid to flow. Does it move fast or does it move slow? And this all deals with intermolecular forces. So this will make sense as you increase intermolecular forces. There's this great attraction between molecules is going to slow down the ability of that liquid to flow. There's going to be great resistance to the flow because the molecules are attracted to each other. Now we have two words that we attach to viscosity, high and low. High viscosity means that you have great resistance to flow, high resistance to flow. It means that there's really high intermolecular forces. So an example of this slow flow, because there's such high intermolecular forces, it moves really slow. Good example is going to be honey, molasses, syrup. Now a low viscosity, this means that it has lower intermolecular forces comparatively, and so it's going to be easier to flow. There's less resistance to flow. That means the substance is going to move faster. So low viscosity, it means that it moves fast. And some examples of this, think about rubbing alcohol or hydrogen peroxide. If you accidentally spill that, man, it just comes out so quick because it has a low viscosity. Okay, so there's the first one, viscosity. Next, surface tension. So this is a measure of inward pull by particles in the interior. Now you and I have all experienced surface tension. It's when you're getting a glass of water, you're filling it up and you're distracted a little bit, and all of a sudden that water's at the top, so you hurry and turn off the faucet and you get this bubble like this of water. You're like, wow, and you come and you slurp it so it doesn't spill. That is a result of surface tension. Now notice this inward pull right here. I drew a little diagram for you. So we have the liquid, the water, and the water, very polar, has hydrogen bonding, dipole, London dispersion forces. There's going to be this intermolecular interaction between the water molecules, except at the very top. At the very top, we have these water molecules, and they're being attracted downward, but there's nothing attracting it up. Whereas, see this molecule in the middle is being attracted upward and attracted downward. That's true for every water molecule in the interior, but at the very, very top, there's only this net downward pull. There's no water molecule at the above that to attract it up. So you get a net down, and now pulling down. And the greater the intermolecular forces, the greater the surface tension. You've maybe done the little experiment where you count how many drops of water you can put on a penny, and it's crazy. It's a crazy amount, like 50 drops that you can put on a penny. If you put soap in the water and put drops of water on the penny, it's a fraction of the amount of drops, and it's because the intermolecular forces have been disrupted. There's not this same downward pull, this inward pull to the interior. So that's surface tension, almost as if there's a little film on top of the water. Really quick little example of this. When I was young, we lived in a very small town when I was about 4 or 5 years old, and there was an old mill that was shut down with a little stream, kind of a small stream that would come out of it. So my brother and I would go and look, we called them, well, they were little skeeter bugs, little spiders that can float on the water. Those weigh less, they have less force than the tension that pulls down, so they can actually walk on the water. And my brother and I, we called them Jesus bugs because they could walk on the water. So surface tension, if that helps you remember it. Cohesion. Okay, cohesion, this is attractive forces between like molecules. Key word here is like. Now I want you to visualize the old temperature probes that had mercury in them. Mercury is very, very attracted to itself, very cohesive. And if you look at those old temperature probes, look at one day, you'll notice that the mercury goes up. It is a convex, it goes up. So you actually have the little mercury higher than even touching the walls. So here are the walls, and the mercury is above it, like this. It's not even touching the walls. It makes this bubble because the mercury is attracting to itself. It's very cohesive, and it makes that bubble on the top. Now to contrast that, adhesion. Adhesion, this is attractive forces between different molecules, and a really good example of this is water inside a graduated cylinder. So you put water in the graduated cylinder and it becomes concave. It goes down, and I drew it right here, concave. And when you look at the water, the very bottom, you know that we call that the meniscus, is as if the water climbs up the edges of that graduated cylinder, and it's because the water's attracted to that glass, to the glass. So it's the adhesive properties that the water's more attracted to the glass than to itself. Next, capillary action. So this is when a liquid moves in a small tube. We have tiny, really thin little capillary tubes. When it moves through a small tube as a result of surface tension. Now, a couple of places where you will see this, great example, paper towels. So you put a paper towel on a spill on some water, and you can see the water begin to absorb. That is all capillary action. It's the liquid being attracted inside that tube, and it moves through the structure of the paper towel. Another place inside your body that it happens, kind of neat, it's your tear ducts right there. When you cry, there's not a little pump that pumps those tears out. It's in your tear ducts. When fluid fills up, the fluid will flow through a little tube and it comes out as tears. That's your tear duct, capillary action. Kind of neat. So there are some descriptive words, some vocabulary that you need when you are talking about liquids. Hope that helps. Have a wonderful day. Thank you.